Okay, thanks a lot everyone for having me here. You gave me the opportunity to know that I have a stalker. So, before I start with this, I'm going to talk about the general stuff that I want to cover. So mostly, as Jessica said, we focus on when we're writing code, we're like, it's going to be compiled or interpreted or whatever it happens to it. And then some computer is going to just execute it. But what we forget most of the time is that some poor soul at some later stage might have to read this. And it could be us, it could be someone else. And so I gave this talk somewhere else, and everyone started talking about accessibility. So before I get to this, I am completely blind. I just see light and the lack of it. So the first thing I get asked is, how do you even program? I can tell you a lot more about that after the talk. I don't want to get into the specifics here because everyone will be bored out of their mind. So when I was talking about this, the talk turned into, hey, let's write good code so that blind people can read our code. I'm like, no. And to actually make you understand where I'm coming from, I'm gonna ask you a bit to try and close your eyes. And I'm not going to be able to check if you have actually closed your eyes. So yeah, I'm going to just trust you. So a lot of you have probably had the opportunity to work with legacy code, which is code that has not been written by you, but has been passed down to you through generations of programmers. Or maybe it was a library that you had to use, and then something in it wasn't working, and you had to go and poke around in it and figure out what actually went wrong. So, so imagine you're dealing with one of these, and you have a deadline for tomorrow. And there's this killer feature that everyone wants to have, your customers, if you have a company, or if you're working for somewhere, they're like, hey, we want this tomorrow. And then you want to get this to work, but the library or the code doesn't really make sense. How do you feel? Yes, load that feeling up. That's probably very frustrated and angry. Okay, so imagine in this alternative reality, my apparition appears in front of you and says, I know where this guy lives. I know his address, and I can actually magically teleport you to his house. But before I do that, I want to, like in those spy movies, they open a wardrobe or a closet, and there's lots of grenade launchers and flamethrowers and stuff. I'm going to give you access to all of these, and then you can do whatever you want to this guy. Now, imagine what you would do to him. Turn that into an image. Insert that in the slide. And then you have the image that I should have put in here. But yeah, it's not really a pleasant image. You can open your eyes now, I guess. So, but why does this actually happen? What actually leads us to this stage? And I have a few theories. But the biggest one is we are all responsible for code quality. And you read a lot about this, but it never actually internalizes. So when we're writing code every day, we are faced with these micro decisions on, should I write this if statement here inside the while loop, inside the callback, inside the class, or should I just move it outside? And then we say, I'll just write it here, and then I'll just come back to it and fix it. And then we're like, there is an if statement inside the while loop, inside the function, inside the class, but someone else has already added to it, so why not? I'll just go add to it more. And there is the developer level, but if you also go higher, like in the product owner level, we have the, hey, let's come up with the killer feature that all the customers want to use. And who cares about code debt and technical debt and all that stuff? Let's just get that feature out the door. Which is what happens, don't tell anyone, a lot in big corporations like looking that up. But the bigger, my point is the bigger you get, the more dangerous this becomes. And part of it is also the decisions that we make every day. And I want to show you what happens. So when you, this is going to be a long description of a chart. I hate charts, but for some reason you guys love charts. So I'm going to try and explain this in a chart. So imagine you have an x-axis and a y-axis, and the x-axis is time, as always. The y-axis is output. So what happens when you don't actually take these micro decisions into account and say, hey, let's do this, let's hack this now, and then let's just get this out the door today instead of worrying about what happens tomorrow, is there is a really massive increase in productivity in the beginning because it's new and shiny and everything is really happy and beautiful. And then at some point, stuff starts breaking. No one knows where to fix it. They throw more people at it. It increases for a while, and then it just keeps going down, goes down past the x-axis, and then the productivity goes to like minus. It's like the output is not even, like we're going backwards. We're realizing something that we should have fixed 10 years ago is actually coming back to bite us now. So a lot of these decisions have an effect on us today, but like the effect has actually begun a long time ago. So when I was talking about this to a few colleagues and a few people outside the workspace, they were asking me, so how do you think this comes around? So how does this happen? And my biggest question from those people was, how do you actually choose the tools that you want to use? How do you, like for example, you want to go for a new programming language. Like let's say I love PHP, just because I used to do PHP for 6 years. Don't hate me, sorry. So like let's say PHP. When we say PHP, what comes to mind? Anyone has any ideas, shout out.
Bad.
Okay. WordPress, cool, okay. So WordPress means dynamic, fast, quick, right? Like you want a website, you can build it in 2 days. Cool. Or like, I don't know, let's go for something else. What about JavaScript? What do you think when JavaScript comes to mind?
Unicorns.
Okay.
Two-made frameworks.
Okay.
Cool back hell.
Yay, okay, yeah. So what happens is when we usually think about the tools we use, maintainability or readability is not really one of the stuff that comes up. Like, how readable is this? How maintainable does it get down the line? Callback hell was a really good catch. But like usually when we think about, hey, should I use, I don't know, like JavaScript or PHP or Go or I don't know, Java, everyone is like, two of these are statically typed, 2 of them are not. So should we go for dynamically typed languages or not? Or should we go for faster because Go has asynchronous, but well, Java does that too in a weird way, and PHP is kind of object-oriented and kind of not. And Java. So like no one actually says, okay, so if we start writing code in this language, how readable is it? Like I actually, for research for this slide, I actually went to all the programming languages that I knew, like all the websites. None of them list readability or maintainability as the feature of a language. And I think a language has a lot to do with that. I'm going to give you a demonstration of that in a bit. Not with code, hopefully. But yeah, I'm going to give you an example that you can hopefully relate to. So my point, in everyday lives, we don't really care about the readability and maintainability of our code. It does matter in the overarching situation, like 1 month later we do realize, crap, this has turned into a hell, whether it's callback hell or another kind of hell. It could be integration hell. But whatever it is, we kind of realize when it's too late. And when it's too late, it's like too late to fix it. And now you have to go and ask people for permission. Hey, can you give me 2 days to go and fix this? Can you give me 1 month to write this project? Can we stop this whole product for 6 months so that we can write another one from scratch? And of course, everyone's going to say, what? No, you're crazy. We're not going to do that. So what we want to do in an ideal situation is to take proactive measures so that this doesn't happen in the first place. Of course, we're going to make wrong decisions. Of course, we're going to say, hey, let's abstract out this code. And then it turns out to be a wrong abstraction. But over time, we're going to sharpen this tool and get better at this as we practice to do it in a way that is more proactive as opposed to reactive. So, yeah. You remember that guy that I told you about, the guy that you killed in all ways of horrible ways? What if we could actually understand each other from the very beginning? What if it never got down to that level? What if he didn't have to write that crappy code and then get killed for it? Sorry, I'm not talking about terrorism here. I know I'm Iranian and you might think that, but I'm not. So, but to make it more serious, what if we actually thought every day about how our decisions are going to impact other people and ourselves down the line, which is really hard. Like you see this when going to the gym. Like how many of you even go to the gym? Can you clap? Why are you so tentative? It's like it's not a bad place to be. It's not like a coffee shop in Amsterdam. But okay, and how many of you don't? Yeah, okay. So as you can see, it's really hard to convince yourself that something is good for you down the line. And you would rather go for instant results, right? So I'm going to propose one language, one tool to rule them all. No, not really. But I'm going to just show you how Go could help you write more readable and maintainable code. Take this with a grain of salt. Every language has its own benefits and its own disadvantages and stuff. You can do all these stuff in other languages that you do every day. But as I said, the point is more the mindset, not the tool. But I'm going to use this to tell you how you can actually, when you're looking at a tool that you want to start using, how you can check if it actually reads them, like meets the maintainability and readability requirements that I came up with. It's not really a standard, but you can pretend like it is. So, so yeah, why is Go a good language for this? Well, for one thing, Go is really stupid, like super stupid. Like it discourages one-liners. You can't put, so like I remember reading this JavaScript code that a guy wrote in one line, and it could do face recognition, and it was all in one line. I didn't really understand that. I don't even know if it would work, but supposedly it does. So don't do that. I had a friend who was a fan of functional languages because he said there is so much you can do in a line. Yeah, yes, there is so much you can do in a line, but your brain needs to process that too. So like when you want to read functional code, a lot of times you have to go inside out, like figure the innermost function call, work it out until the very first function call and say like, okay, so this is actually calling a loop that is sending an email to 10,000 people. Cool, okay. I could have written this in 5 lines, but it wouldn't have been just as cool. So yeah, Go discourages that. Like there is no way to do this. So that means it's easier to understand. For example, when you're reading a line of code, your brain doesn't have to go, huh, what's happening here? 3 stuff, like 3 functions are being called in one line. You could still get around this as you can do with anything else. But like you have to be really determined. Like I want to write crappy code and I don't care and I want to do it. And whoops, I lost my track. Okay, I lost the. Okay. So let me recover. I'm crap at this. Yeah, could someone just tell me what showed up?
No encourages explicit.
Okay. Oh, all the guys that said use PHP and JavaScript, and we have Ruby people here, right? Yeah? Yay. So what happens in this code, like I used to be in this team that used to do PHP, and they called a lot of external APIs, and they didn't actually check if the API call succeeded or not. The biggest problem was that PHP didn't make it mandatory for you to handle the errors. You could try it and catch it if you wanted to, but you could also let it slide. which meant like for us at that time, it meant like a £3 million loss in 2 days. Yes, that company did go broke. And so it started with a lot of tries and catches that never were there. So with Go, the first thing that caught my attention, and you also, again, as I said, you have this in other languages as well, is that you have to catch the exception or the error or otherwise there's going to be a compiler error that tells you ahead of time, hey, there is like an error here, you shouldn't just let it be, just do something with it. Even if it's like, if you look at the Go code, most of it is like, hey, log this, log that. And what we found at Booking is that these crappy copy-paste log lines are actually very useful when stuff crashes. So even though it looks the same, it does end up to be super useful. And languages like Java is recently cracking down on the stricter usage of exception handling and stuff like that. That is a thing that you could be super reliant on if you choose a language that supports or provides you a facility to do that. So yeah, and the other thing is, wait, I forgot this again. I need your help.
It's very easy to write an application that can pass good.
Yeah, cool. So if you have used dynamically typed languages or Java, you have seen a lot of this where you want to write a tool that parses Java code or PHP code or Ruby code or, well, in Ruby it's easier, but JavaScript code, and does something with it. For example, static type check, static code analysis and stuff like that. And in Go, that is super cool because the compiler is actually written in Go. So you can easily write some piece of code that loads up the Go code, looks at it, and then turns that into a way of, they call it the AST, where you can actually look at it in your code and say, it's kind of like a tree. There's an error handling here and stuff. And I will show you in a later slide that there is actually a tool which uses this to do a lot of checks, which is super useful. Everyone hates it because it keeps giving you errors of all the stuff you did wrong. But it's very useful if you use it in the right way. But I'll get to that. OK, so Go as a language can only do so much. Like you have this in all the other languages as well. They can only do so much without you doing a lot of the work. But Go does have a few tools that are useful. And I'm going to show you some of them. This is, again, in other programming languages. Don't hate me. I'm just saying use them. So the first one is GoDoc. It is similar to Java doc or PHP doc or Ruby doc or whatever language doc. What it actually allows you to do is to turn very simple comments above your functions and packages and classes and all that. Well, in Go, they call them structs, into documentation. The cool thing about this is that it comes with the Go compiler and the Go tooling, which means if you have Go installed, you can read the documentation. Now, in other languages, that's not always the case. But hopefully, this should mean that more people write documentation. And then, because it's now easier for people to go and read it. One of the complaints that I always got from people was that, hey, I don't actually have the software required to read documentation or to write documentation and all that. But like this should make it hopefully much easier for people to write documentation if they want to. The keyword is want to. Yeah, so, oh, crap, I did that again. I hate these animations. Yeah, so getting past the documentation. Oh, this is the cool tool I told you about. Go Meta Linter is a tool that uses a lot of linters. People in Ruby probably know this concept. People in JavaScript also know this concept probably. For those of you who don't, Linters are basically programs who go through your code, check some stuff, and give you a warning if they find a problem. These are outside the compiler or outside the interpreter, and that's why having them around is super useful, because the problem is that your compiler cannot catch everything, like anti-patterns and stuff. Otherwise, people will complain all the time, like, oh, I don't want to put my code like that. So, so they came up with this idea of having something called Go metalinter, which takes like, hey, there's an if statement here, and there's no else block, and you can't believe how many times the RTEX stack has failed because an if doesn't have an else block. So it's a lot of cool stuff to integrate into your build system. If you use, for example, Jenkins, or I don't know, any other system to do continuous integration, this is super cool to have in your tool belt. And Go rename and EG. So these are usually when you use languages, they don't have their own tools to go and refactor your code. You need to rely on an IDE like IntelliJ or whatever to do that for you. And the cool thing with Go, as I said, is so that you can parse Go code with Go code. So what happens is we actually have community projects that are helping you refactor your code. So an example is Go rename. Go rename is an application, well, that allows you to rename a variable. Super useful. No, but like the cool thing is, for example, when you're using VI or Vim or Emacs or whatever that doesn't have all those cool stuff, through Go rename, you can have that functionality for free. There is also EG, which is my favorite tool. So EG is example-based refactoring. What this does is you just write some piece of code, say, okay, whenever you see this, convert it to that. So for example, let's say you want to change your APIs. You used to do things a certain way, but now you want to change it. We see a lot of that in Bookings code, which is like 20 years old. So like at some point, someone came in and decided, hey, we want to call these customers. Now it's, I don't know, perspective customers and all that. And then when you're going through the code, you see all these variable names like PC, EC, and GD. And I'm like, who the, like, I don't even know what this is. So using something like EG, you could go through all of these in your code and turn all the PCs to prospective customers, or ECs to, I don't know, existing customers. So that is super easy to do, and it's type safe, which means it doesn't get, it doesn't do crappy stuff. Like one of my problems with PHP was if you use an IDE, it would go and do all sorts of weird stuff in its refactorings. So you don't have that because it's Go code that's doing the replacement. So that is super useful. And since all the talks I've seen give some quote, I couldn't help it. I thought I would give a quote. So this quote is from Martin Fowler. He gave he said this in 2008. We are now in 2017. I'm giving this talk 10 years later, talking about the same concept, which goes to say we don't really care about this that much. It's an issue that has been persisting for years. So yeah, so his point is that any fool can write code that a computer can understand, but good programmers write code that humans can understand, which is a good point. It doesn't mean we're all fools, but you get his point. Yeah, and yeah. So, okay, I want you to close your eyes again, please. I was too ordained there. So yes, again, I'm not going to check your eyes and stuff. So if you didn't close your eyes, just stay quiet and pretend like you did. And remember the guy that you killed in all those sorts of horrible ways, the doomed programmer, the poor guy, and just imagine that you would go up to him. Like I would appear and say, hey, I know where he lives, and you're like, yeah, take me to him, take me. And then I take you to him, and then you hug him and say, your code is awesome. I've not seen a code that is so cool. and like you actually took the time to think about all your decisions, all the little decisions that you were making. You didn't go 3 days without coding because you were thinking about the best way to put this, but you did your best at the time and you took the time, and that's so cool. And I just wanted to hug you for this and thank you. And instead of killing him, it certainly lowers down the murder rate. I think that's super cool. But you can open your eyes now. And I'm a bit early. I finished this presentation earlier, but I hope that means more questions. So yeah, you can get in contact with me through the links that you see on the screen. My Twitter name is just because I hate people just putting links on their slides and not talking it out so that I would hear. I'm going to do this. I'm going to see, yeah, so my website is myname.com, so that's parhamdoustdar.com. My Twitter is pd90. My email is me@parhamdoustdar.com. So you can reach me on any of those. I'm also in the Slack channel for the conference. You can just message me and just come up to me. I don't bite. I haven't done that for a long time. So, and you can also ask your questions now.
Any questions?
Yeah.
Why Go and not like Rust or other things? So you say the tool set is great, like
Yeah.
And it discourages one-liners. Are there any other languages that you really like that kind of do this thing as well?
Yeah. So personally, okay, this is very subjective. Don't hate me. But like personally, I really like languages where these languages don't try to guess what you did, what you meant to do, and don't create ambiguous like understanding. So like for example, Perl is great at trying to guess what you're trying to do. That means like your integers are sometimes strings, your strings are sometimes floats, and a lot of that. So so the more strict the language is, the more declarative it becomes, and the more clear and concise it is. Like Python is a really good example. It got a lot of hate at the beginning because of the indentation and all that. But like they put this, like Go now actually reformats your code as it compiles it. So yeah, that's another way of being Python. But yeah, so the more strict a language becomes, it's easier for people to know what's going on. Because a lot of times you have to also take into account that you're going to hire people who have not used this language before. So like if you do this with PHP, people coming from Java are going to say, okay, this PHP didn't give me an error, so probably there is no exception going on. And they wouldn't read the code, and then they would send requests to some API. That wouldn't work. The company would lose a lot of money and go broke. And yeah.
Okay, thank you.
Go ahead, Steve.
So pretty much every successful business ends up with crappy code, but not every developer sets out to write crappy code.
Yeah, that's true.
Do you think that there's something telling in that from the fact that all the ones that set out and follow best practices end up failing?
Yeah. I actually have been in those exact circumstances. I went into a company that was selling a lot. I did all the best practices, and they stopped selling a lot, thanks to me. So yes, there is a balance, a fine balance that you need to strike. And that's the thing I was saying, that if you don't take 3 days to talk about, hey, should we have an interface here or a protocol or whatever your language is calling that, and then should I just go ahead and implement this? Because so what we were doing was we were over optimizing in terms of abstraction. So like, hey, let's put an interface for accessing the database, because what if we decide to change our database at some point? No. But that's not, I mean, it's great to read in articles and to Google them and read them, but in the real world, no one changes the database without wondering how the syntax change is going to affect everything. So you can't just put in a different database, and expect stuff to work. So yes, there is a fine balance, but the point I was trying to make is when you are conscious of your decisions every day, you would go for a lot of options that are a bit slower, as opposed to 3 days. It's like 10 minutes extra, 20 minutes extra, and then you still get to have the clean code as opposed to, hey, I'll do this now, I might not come to this, and then all this dredge just keeps gathering up and getting bigger and bigger, and now you have to care about, hey, when's the best time to do this, and when should I even care about that? So what I've noticed is, for example, using booking as an example, they are much more careful writing new code now because they have a pretty good understanding of what happens when they don't. And the cool thing is it doesn't cost them any extra time. So like if there's a team of senior developers who have been here for 7 years and know what some crappy code can do if it's legacy code and it's not clean, it's not like they move slower. They move at just the same pace. It's just that they don't make those micro decisions that would save 2 minutes, 3 minutes, but then at the end end up costing them days. Does that answer the question though?
Yeah.
Right. So in a normal company, you'd have to. I'm speaking as a dev. You'd have to talk to the product owner.
Yeah.
And the estimates usually come from us, and we are very, very bad at estimating. So we always end up with a tight deadline.
Yeah, that's true.
What sort of tips do you have for the product owners to actually let us work like we want? Because no dev wants to write crappy code, but we all end up writing a little bit that we're not proud in order to make it to the deadline.
So I have no advice for the product owner. I have advice for developers.
All right.
Strengthen your soft skills and persuasion, because technically that's what you're doing. But it does depend on the product owner. If you can convince them to allow you to do this, that's cool. If not, they will learn the lesson at some point. Like all my product owner friends are like, yeah. And then 10 months later, hey, that thing about clean code you were talking about, how does that actually work? I'm gonna tell my team to start working on stuff for 2 months and try to refactor the code. So what I usually say, and what I learned to do was make it a habit, and you don't have to make extra estimates for it. When it becomes a habit, when you don't actually think about, hey, should I put this code here or should I not, and stuff like that. And when you have consistent sessions all the time, sharing knowledge between the team, then you don't even need a product owner to say, hey, I need extra time or not, or whatnot. Everyone's just going to do the right thing. One thing that I've noticed a lot is that in teams, like with 4 people, you have 3 people creating crappy code and 1 person trying to clean up everything. That doesn't work. You have to teach your people you're collaborating with to actually care about this, and send them to me. I'm persuasive, but no, I'm just joking. I just use flamethrowers and grenades. but yeah, technically, the more people you can get on board, the easier your job becomes.
Thank you.
Yeah, sure. Sorry if none of this is like hard answers, like programming questions that you do. Like many of this is very soft skills and very very on the spot, and there's not really a good answer for it. It's that's why this has been going on for years, because like everyone is trying to find their own balance, their own point at which everyone's like, I finally know what readable code looks like. So we are just in it, trying to figure out the best way. But as long as we're all on the same page and moving together in the same direction, this is going to pan out perfect.